The first battery was created in 1799 by Alessandro Volta. This was not the first device to create electricity, but it was the first device to emit a steady and lasting current. There was a limit as to how high the layers could stack, because if it was too heavy, the brine would be squeezed out of the cloth. The metal discs would also corrode quickly, which shortened the battery life.
It was first proposed by a British chemist named M. Stanley Whittingham to use metallic lithium for the lithium battery. However, metallic lithium presented health and safety issues. Metallic lithium is highly reactive and will ignite when exposed to air or water, making many of the batteries explode or catch on fire. As a result, research moved to develop batteries in which instead of metallic lithium, only lithium compounds are present, being capable of accepting and releasing lithium ions. The lithium battery is composed of a positive electrode, which will be a metal oxide. For this, lithium is combined with oxygen and a transition metal such as nickel, manganese, or iron. The negative electrode will be composed of carbon, and the electrolyte will be lithium salt in an organic solvent.
The flow of electrons creates an electrical current that can eventually give power. The simple battery contains the anode, the cathode, the electrolyte, and both a positive and negative collector of the ions, shown here on the clip. The positively charged lithium ion moves from the anode to the cathode when giving charge to an item. The lithium ion moves from the cathode back to the anode when it is being recharged, allowing for the battery to be used multiple times. This is the image of the SEM of the lithium battery components.
For improved materials and alternatives, lithium-sulfur batteries are being studied. Companies claim that the new batteries will have 40% higher energy density and lower production costs than today's lithium batteries. However, there is an issue since the electrodes degrade too fast for commercial applications right now, but a number of institutions are working on a solution.
Lithium was discovered in Sweden as the mineral petalite by Johann August Arudson in 1817 from an iron mine. It was first isolated through the electrolysis of lithium oxide. Lithium is not found in its elemental, metallic form in nature. Lithium can be found in igneous rocks and from lithium chloride salts found in brine pools. The largest producers of lithium include Chile, Argentina, Bolivia, and Australia.
For millions of years, minerals from the mountains leach into the ground. Then they collect together and form huge salt beds, rich in lithium, sulfate, potassium, and boron. Companies like SQM pump water up through the beds and store the mineral-rich liquid in large ponds. From there, it's up to the sun to do its thing and evaporate away the water, leaving the minerals and salt behind.
Lithium is a vital element to our society. It can be found in medicine, nuclear reactors, air conditioners, metal alloys, and most prominently in batteries. The average person utilizes lithium on a daily basis, where it is found in their phone, laptop, or hybrid car batteries. It is a very versatile metal, being used in small doses to treat illness or in large applications in aircraft metals and lubricants. Extraction and production of lithium has helped many economies to boom and jobs to surge. In the commercial industry, the widespread use of lithium has advanced technology immensely, making things like cell phones smaller and more powerful than ever. With this rapid growth, industries that depend on oil are being threatened as batteries and electric cars become more popular and cheaper.
Lithium is a very interesting metal. When on fire, it is very difficult to put out. You cannot use water, you instead use a powder fire extinguisher. Lithium also floats on water but reacts with it to cause an explosion. Lastly, in small doses, it can treat mental illness but is toxic in larger doses.